Good morning and good afternoon. Welcome to our webinar, Diagnostic Simulation of Vehicles Made Easy. My name is Mario Hoppen. I'm the head of sales at RA Consulting. I'm with the company since 2003. I will be moderating the webinar today. My colleague Alexander, Dr. Alexander Karmazin, will give you an introduction into the general topic, diagnostic simulation, and also explain our DiagRA S simulation solution. Just in advance, we have been using DiagRA S, the simulation product in our company for many years to test all our diagnostic solutions. And we also use it for product presentations and product trainings for the diagnostic products. Our customers are using the tool in a wide range of application scenarios since some years. Following on Alexander's presentation, we will be happy to answer questions you may have. Please use the question and answer button, the Q&A button, to tell us your questions. Yeah, and now I wish you an interesting 45 to 50 minutes. Alexander, it's your turn.
Great. Thank you, Mario. So thank you for your introduction. Now I'm turning over and then I'm starting with my part of the webinar. So I will tell you about vehicle diagnostic simulation with our tool DiagRA S, and I will convince you that it can be made very easy. And yeah, this is our main topic for today. The short agenda for our meeting, I will introduce RA Consulting and me as a speaker for my talk today. Then we will continue with a simulation of diagnostic communication with our tool DiagRA S and requirements for doing for vehicle simulation tools. We will create simulation from diagnostic trace files, some recordings of the communication with ECUs and vehicles. Then as a next topic, we will create and edit simulation files with help of configured ODX databases. And I will end up the webinar with a summary, and we'll turn over back to Mario for the questions. And I hope you will have some questions, so you just use the F&A button for that and write the questions during the webinar. And we will talk about them at the end. So I will start with the first part. So first about me. So as Mario said, my name is Alexander Karmazin, and I'm working for RA Consulting since 2013. And I was involved in different projects in product and development of our products and services for the customers in the area of ODX, vehicle diagnostics in total, UDS, diagnostic server, DPU API, and yeah, sorry. So I think you expect that I'm sharing my screen. So I forgot to share my screen. It was it was a good thing to know about that. So now you see something, and you see also my picture. And yeah, so I have also added the LinkedIn profile here. So if you wanna connect with me, or you have some questions regarding DiagRA S or regarding our products, you are free to contact me. And also QR code here. It's a very easy way to connect. And about me, I forgot only to mention SOVD. So I was also representing the company in the SOVD standardization. So it's standard about new generation of diagnostics, and it will be published this year as an ISO standard. So then we switch to the next slide, and I introduce you our company and our general management. In the middle of the picture, you see Armin Rupala. This is our founder of our company. 35 years ago, he started the company as a startup, and yeah, he's now still doing business, and I'm really happy to work with him. From both sides of him, you see our general managers, Andreas Hege and Stefan Weichle. What we are doing, so we are developing products, also software products for measurement, calibration, and functional tests of control devices and vehicles, and also for diagnostics of electronic control units and vehicles. Also, we provide services it means we provide customized solutions for the customers. Customers come with a specification of their requirements to us, and then we develop a custom solution. And yeah, most of the time, these solutions are around this main topics, what we are doing, so around measurement, calibration, and diagnostics. And also we have colleagues doing research and innovation in the field of future technologies, and also helping us to investigate new technologies for further development of our products. So Array Consulting is located in Germany. The headquarter of the company is in Brussels. And we have also subsidiaries in USA and China. And we have also some shares like Emotive. Maybe you heard about that company. It is the leading company in the field of OTX solutions. And yeah, we will also shortly talk about the compatibility of DiagRA S with Emotive solutions. Good, let us start with the main part of our webinar. I will talk about simulation of diagnostic communication, and we will start with requirements for DiagRA S, or in total for a diagnostic simulator tool. Most of these requirements are derived from the requirements for testing diagnostic tester. So, I mean, there you have kind of diagnostic tester tool which needs to be tested with different combinations, also with different vehicles, with different ECUs, different protocols, and yeah, you need to test it with different behavior of ECUs, including failure behavior. And often these vehicles are not available or not even existing yet. So if it's early development, and also it is really hard to get or to force ECUs to do failure behavior, like doing no response, producing wrong responses or wrong response sequences, and so on. And there is also a use case to test diagnostic tester or diagnostic tester sequences with different data definitions, because UDX data might be changing from one version to another one, and we still need to assure that the tools are working fine with these changes. And also the use case, another requirement is to test different hardware interfaces for diagnostic tester, test diagnostic tester tool on different platforms, test performance for doing diagnostic communication, and also run diagnostic sequences probably in CI/CD environment, and test the business logic. Yes, and this is why we developed our tool, DiagRA S. And DiagRA S is able to simulate one ECU or multiple ECUs or the whole vehicle. It provides different standardized APIs, which are just installed together with a tool on your PC. And the testers, or diagnostic testers, which are compatible with these APIs, can access DiagRA S easily. So like pass-through RP1210 or GPDU API, these are the libraries we are installing together with DiagRA S, and any diagnostic tester which is compatible with these APIs can talk to DiagRA S, and everything runs in this case in software, so you don't need any hardware. And yes, and surely that way works also with our tools like DiagRA D, Silver Scan tool, also with Emotive Open Test Framework and OTX runtime from Emotive, and any diagnostic server compliant to the ISO 22900-3 is also compatible to DiagRA S. And yeah, this is really a good way to test your software if you are compatible with one of the standards. And if diagnostic tester is not compatible with the standards and using some other way to communicate, or maybe it is not possible to set up, to configure which DPU API or pass-through API should be used, then there is another way to do that. We will come up to that later. We provide also a socket CAN-based solution, but it is not part of a standard delivery yet, at least yet. And yeah, we support most of all typical networks, buses, and diagnostic protocols like UDS, OBD, and J1939, and yeah, everything for CAN, KFD, and DoIP. The simulation can be run in with UI or without UI in the command line mode. And I already told previously that we have a hardware, so-called hardware simulation mode. In this case, DiagRA S just monitors some physical CAN bus, and yeah, listens to the messages on that. And if in case some requests are found, or diagnostic requests are found, which can be answered by DiagRA S, then DiagRA S just sends responses back over CAN bus. In this case, it is completely decoupled from the APIs we are providing ourselves, but you would need some hardware. Let us talk about benefits of using the diagnostic simulator. So it's available everywhere. It is very good to learn vehicle diagnostics. Even our engineers or our colleagues using this in sales for presentation of products for customers, and as well as we are doing trainings for our products for customers with DiagRA S, because it allows you to just to show yeah, to go through much more combinations as with hardware, because in hardware you're still limited to that concrete hardware. Good. Also learning usage of diagnostic software, understanding diagnostics, and yeah, these are typical benefits from using the simulator. And there are also no cost for switching between test setups with DiagRA S, and very low costs and short time for creation of test setups. This is where we will go through later, how to do that and how easily it can be done with DiagRA S. So let us start with some basic idea about simulation servers. So DiagRA S has different ways how to communicate. I told about that before. And we provide pass-through DLL and RP1210 DLLs, which are just installed on your PC according to the standards. And these DLLs connect to DiagRA S over inter-process communication, and diagnostic tester, which is compatible with both with one of these standards, can talk to DiagRA S in that case. Internally, DiagRA S uses a simulation format to describe vehicles in ECUs, and this simulation format is based on XML. We will later look inside, and that's really, if you are familiar with XML, it's really easy to understand the model for the simulation. There might be some more advanced things you need to know, but most of the basic models are really easy to understand. So I said here on that part that DiagRA S is used. We have also a command line version of that, and it can be run in CI/CD environments, for example. It should work the same way like DiagRA S, but it just doesn't need any UI, and yeah, just more lightweight. Good. So the next way is to connect to DiagRA S as a DoIP. Diagnostic tester, which is just looking for in the network for DoIP capable devices, will found DiagRA S as a DoIP gateway, and it will be no difference for diagnostic tester between a real gateway or the simulator, because DiagRA S implements the whole DoIP standard. So we are listening to all networks available on the PC and to whatever is allowed by the firewall. And all requests for port 13400 for UDP and TCP will be processed by the tool and will be answered back to the tester. And the same works also with a command line tool, which is delivered together with DiagRA S. Yeah, and the simulation is based again on the XML file, and actually this more or less the same simulation file as used for pass-through and RP1210 can be used here. It just needs additional details for configuration of DoIP communication. So the tool has to know which DoIP addresses, as logical DoIP addresses, are supported by ECUs. And more or less that's it. So there is also additional configurations like VIN number for the whole vehicle needed, but it's really easy to transfer or transfer your data or your simulation files from CAM to DoIP or to support both. So the next is DPDU API. This is another DLL which is installed together with DiagRA S. We install it in both 32-bit and 64-bit versions. Internally, it uses DoIP communication to reach DiagRA S for DoIP protocol. For CAN-based protocols or CAN-FD, it uses pass-through delivered with DiagRA S and communicates to the tool. For the tester, it is just a normal DPDU API, which is installed on the PC and can be used. So the next point is hardware simulation. In that case, DiagRA S uses any VCI, which is supported by the tool to connect to some kind of physical CAN bus. DiagRA S listens to messages on CAN bus, and in case there are some requests, also diagnostic requests found, it tries or it just sends responses to the physical CAN bus. On the other side, there is actually any kind of diagnostic tester which is communicating with any VCI to this physical CAN bus. We just don't know about that. And we do this, for example, with a simple quasi-T connector. It's available online, and you can build also simple CAN bus yourself or whatever, but it's the easy way to do that. For DoIP, it's also possible to support a use case if your diagnostic tester uses DoIP over OBD port. Then in that case, you will need kind of the adapter cable from OBD to Ethernet. And in that case, then the tester is connected to kind of an Ethernet network. If DiagRA S is able to connect to the same network, then it will just listen to the messages and will respond back. The main problem here is the firewall, so because the setup here doesn't cost much money, but the firewall might be the problem, so you need to configure it and to care about that. Good. So then we are actually done with the first part, and now I wanted to show you this in work, how you can use DiagRA S. I will open the tool and also open the DiagRA D tool from our company. It is our diagnostic tester tool. First, I will I will show you DiagRA S. So it's the main window of DiagRA S. Shortly explaining the user interface, we have a main menu, some toolbar with a few buttons here, a short description about the simulation project. Then we have a table with our simulation servers. And I hope from the naming it's more or less clear what we are talking about. So one server was used to support requests coming up from our pass-through, our RP1210 DLLs and DPDU API as well. One server is used to support hardware simulation for connecting to a physical CAN bus, and there are two servers serving for DoIP support, providing the way to receive and reply for DoIP messages over UDP and TCP. Good. So I think it's the basic idea should be clear from that. So now I have one simulation file selected already. This has two ECUs, and from the name of the project, I can conclude it is something about J1979, so it is OBD on CAN. We will look up in the inside of the project first, so I will show you how it looks like. I will use the main menu to open this in Notepad++, but you can configure your any other tool for doing that. I have to collapse some things here because it's it makes the things not well readable. So it is an XML file with version with a reference to XSD, so to the schema. And if you have a proper XML tool, then you can edit this file also manually if you want. And the model is really simple. In this case, we have just very short information about this simulation project, and we have some kind of a documentation of version history. I will skip that part, and then we will have several ECUs which can be defined here. So in this project, I have only 2 ECUs. For each ECU, there is a definition of its address for CAN or whatever for DoIP. For DoIP, it would be looking slightly different. But in total, the basic idea is the same. And in this case, we have a diagnostic module for handling of OBD data. And under this module, there are several services which are defined, so-called OBD modes. For mode 1, there are PIDs, and for each PID, there is at least, or should be at least, 1 response defined, but you can produce a list of responses. And then during the communication, the tool just goes through these lists, and for the next consequent request takes the next response, and so on. So it's a wet way you can reproduce or you can simulate also kind of the measurement process in your diagnostic sequences, where you deliver different responses every time. As you see, the data here internally is something, it is just hex. Also, it is just, these are just bytes and bits. So it's really flexible, whatever you do with this model, but it produces a small issue with editing, because you have to really know what you want to simulate and how to understand these bits and bytes. We will come up to that later, but generally, if you know what you do, it's really an easy way to add or edit data here. Good. There are also other ways or special definitions for other responses, like negative response or so-called multi-response, to simulate response pending, where the simulator will send several times pending message, and then at the end some positive or negative response, or maybe nothing if you want to simulate some error behavior of the ECU. And there is a way to define no response also. We have different modules which can be used and combined in the simulation. I'm going here into much details, but you just have to know you have other ways to define UDS modules, and also there is another so-called module for defining requests and response pairs in the raw format without knowing anything about the type of the data. Good. So now I think it should be clear. The basic idea should be clear enough, and we will go back to DiagRA S, and we will try out to do a simulation. So first, DiagRA S is running, and we see here this server is idle, so it's waiting for connection. I'm switching fast to our diagnostic tester tool, DiagRA, and it is configured to use a scan tool for OBD, and in this case, OBD on CAN. So I will go here to the button part. I need to select the interface, so the hardware interface which needs to be used for the communication. And you can clearly see here there is an interface from DiagRA S. It is, in this case, pass-through in version 0404. There is also a DiagRA S interface for as a DPDU API. We will try them both. So we will try first the pass-through version. And it is already selected. I can finish it by clicking OK and start the communication. So now the data is received by the tool. The communication is running. I will switch back to DiagRA S. And in DiagRA S, we see this server is now running, and the current transport protocol is CAN, and there is a communication info that the tool called DiagRA D is connected, and it has a process ID with this number. And it's a bit confusing here, but the PID in this case is a Windows process ID. Also, we have in the bottom part, we have a trace tab where we can follow the messages which are received and sent by the tool. Yeah, so we see DiagRA D goes over all CAN and sends many CAN frames because I configured that to read this data cyclically. I will try now to update the project. So now the DiagRA S is configured to listen to the project changes, and as soon as something changed in the file, these changes will be immediately applied. So I will change that number, and I expect that 0D, should be vehicle speed, will be changed in DiagRA D. And yes, now it's increased. So before that, it was 128. So let us do it again. Now it will be, so before that, it is 129. And if I change it and save the file, then DiagRA D will display 128 because the model is updated, and then the tool delivers another value. So it's really working smooth. And you can do it also for other ways of simulation. Good. So now I stop the communication. We will shortly try another way around. Do the same over PDU API. I select the PDU API from DiagRA S as an interface in DiagRA D and start a connection. And now the connection is running again. And on DiagRA S side, I'm switching back again. We see DiagRA D is connected, and then communication is running. Exactly. So for pass-through and the PDU API, it is now clear. Now we try the hardware simulation. So normally in the hardware simulation, we don't connect automatically somewhere. So we provide a way how you to select the hardware interface you want to use. And in this case, I would use a quasar interface, which is configured to use a virtual CAN. Virtual CAN channel 1, because it's easier for me now to set it up, but generally the same way works with any hardware you have, which is supporting the DPU API or pass-through API. So I will start the communication, and now hardware simulation server is running, and it is waiting for incoming requests. On DiagRA D side, I will shortly switch to the virtual CAN driver from Quasar, and we'll start the communication. And we expect the same result. And also on DiagRA S side, if I go to the trace, we can see all the messages which are received and sent. Works exactly the same way. For DoIP, I will show you for DoIP in our case. So I have here the project, the simulation project prepared for ZEV on UTS, so the new standard for emission-related, not for emissions actually. Zero emission vehicles have no emissions, but it is standardized by the request from the California Air Resources Board in USA. So, and they reused most of the things from the emission-related diagnostics. So it means the standard is highly related to the emission-related diagnostics, but it's not about emissions. Good. So I have prepared a project for that. I have here kind of generated VIN and logical address for DoIP communication. I have two ECUs having DoIP addresses. They have also CAN addresses, but in that case we don't need to use it. And then on DiagRA D side, I selected the scan tool again and selected the J1979-3 protocol. And also I have selected the DoIP module from DiagRA S. So, and then we can start the communication. Takes a while. And then we are able to read the data. So DiagRA D needs to some time to update. So we see with both ECUs and the related data. And on diagnostics S side, we also see that these servers, also these UDP and TCP servers are running, and also the messages which are received and responded by the tool can be visible here in this trace. Also, we produce other trace outputs specifically for concrete diagnostic addresses to make it easier analyzing what happens for each ECU. Good. So the basic principle is the same. It's really easy to configure and to use. So now I switch back to my presentations, and we continue the creation of simulation files. Yes, so we are now at the point where we are talking about how to create a simulation file. Is it something hard to do, or maybe we can do it easily? Yes, in case you have your trace file with a recoding of the real communication between tester and ECUs or vehicle, then you can import this data to the tool, and then the tool takes every diagnostic data out of that and then creates and fills simulation model with that. We support different trace file formats. Yes, we support definitely our file formats produced by our tools like DiagRA S, Silver Scan tool. Also the logic format produced by Emotive tools. And we support also standardized formats from compliance test tools. And we support also other widely used formats like ASC for mostly for CAN communication, but sometimes there also the DoIP communication can be traced in an ASC format. And we support PCAP files or PCAP NG for importing data from DoIP recordings. Yes, so, and if you are missing some format here in the list, then we can talk about that and support your custom format on request. For importing data, we have several options. Maybe I will not go in details about all of them, so we describe them in details in our user manual. You can configure which functional request CAN IDs shall be known by the tool because they are manufacturer dependent. Some of them, some of the functional request CAN IDs are known because they are standardized for VD, but others are manufacturer dependent. So yeah, you have to think about configuring them before doing the import. Also for DoIP, sometimes the UDP messages are missing. So then you might need just to configure some default value for WIN and logical address of gateway in that case. And there is an option to ignore negative responses when there is no data for them imported to the simulation project. And also there are options to ignore delay on importing repeated responses. So then it just makes the simulation model smaller, and so on. So I think if you want to know more about that, then you have to read a manual or just contact us, and then we will explain how to use or how to understand these options. So now, actually, for that part, I don't have any slides, any other slides. And I will switch back to DiagRA S tool, and then we will try to create our own simulation files. So first of all, I will stop the communication here because DiagRA S was connected to the Quasar virtual CAN. We don't need it now. So I will go to the main menu and click on New Project. And then I will see the dialog to do that for creating a new project. The mandatory field is here project name and project type. So these two needed to be filled. For project type, we have a default value. It is a diagnostic project. For some other special use cases like Gen 1939 or different compliance tests, we have a separate simulation modules. And in this case, you need to switch your project type to that value. But for UDS, OBD protocols, and even for keyword protocol 2000, you need to use the diagnostics type. Good, so I need to input some name for importing data, test import one. And actually, I can select the folder where it will be imported. I will not do this. I can add the ODX database to be configured, and it might be used for during the import. For example, if you have an IST file, then the tool needs to know which CAN identifiers are identifiers for diagnostics for ECUs, and which CAN identifiers are just functional request IDs or just REST bus CAN IDs with CAN signals which have no diagnostic data. And such a configuration is easier if you have a configuration for PD as an ODX database. There are also other cases covered, so you can configure also the folder with PDX files, which are describing each ECU separately. So these two use cases are really helpful because some customers, they have a big ODX database describing everything. Some other customers, they have just a folder with PDX files, where each PDX file describes a concrete ECU. Good. So it is optional, so I will skip this. And then in the bottom part, I can configure settings for importing log or trace file, and I will just add a file in this case. Let us start with OBD on CAN. So I have here an IST file and log file from DiagRA D. I will take DiagRA D file. It's easier. And then something happening and in the background, and several seconds later, we have created a new diagnostic project with a new name, and we see there are 2 ECUs created out of that, and this simulation project is already ready for communication. And we can also open this in the tool and see how it was created and which data is contained and so on. So for now, it is quite easy to understand. Hopefully, we will do the same procedure for PCAP file, test import PCAP. It is still a diagnostic project. I will select the PCAP file with recording for ZIP on UDS on DoIP and add it here, and then the project with 3 ECUs is created. So we just take out only the diagnostic data out of this PCAP file and then ignore anything else. The idea is totally the same as with our trace files. Good. So for now, so far, I hope it is clear how it can be easily done by importing trace data, but we saw already the XML files, and XML is not that comfortable to edit, especially if you are not a specialist in XML. And also, this has another disadvantage. You don't see how the data looks like. So because you just see raw bytes in that case. It might be a good way to do that, but we found another solution for that and said, okay, we want to have more comfort to edit the simulation files, and even with support of ODX databases. And because of that, we provide or we offer professional edition of DiagRA S, having the authoring tool inside. And this authoring tool is a UI for management of simulation files. And then the tool, if it has corresponding definitions, then it will also not only represent all the simulation data in the tool and let you edit it, but it will also try to represent physical values for that. We will see it in action just in 1 or 2 minutes. Good, and we deliver in the professional edition, we deliver also a tool for manual testing simulation files. I will skip that topic for today, but it's really helpful because then you can test the simulation model without having any communication running, without needing any diagnostic tester. You will just play around with that, and it's really helpful. And you can also automate with that tool or with the supplied tools the process of importing the data from trace files. So there is a command line interface, how to do that, and then you can automate the creation of new simulation models with that tool. So I said for some data we try to show also physical interpretations of that. Especially we deliver OBD and OBD and UDS definitions together with a tool, and then the tool recognizes automatically this data and then tries to interpret data, and you can browse it. We will see it in action. So for this year, we planned also to support J1939, but it's currently in work. And yeah, you will be able also to edit physical values. So another way around, so not just editing raw values, but editing physical values and then get raw values back and then save them in the simulation file. And there is also a good way you can start editing the message just by generating kind of response. We will see it in action as well. The same idea like we did for OBD works also with your custom generic ODX databases. So you can configure kind of ODX database to be used in the tool, and then the tool finds out which diagnostic layers from the ODX database are matching to the ECU definitions, and then helps you editing inside of the tool. And yeah, this feature supports also all ODX versions which are available, which are used by our customers in the field. Good. For that part, I don't have any other slides, and so we will switch back to DiagRA S, and yeah, I will start this authoring tool. So you can easily do it either from toolbar or from main menu. And in this case, another tool will be started. It requires this license for professional edition. So now it started for me on the other screen. I need to move it to the main screen where I'm doing the presentation. It takes just a while. Yeah, so now here it is. It's a data manager tool. It has more or less a similar user interface for main menu and toolbar as the DiagRA S. The difference is here on the left, we see kind of a tree view, and in the tree view, we see different nodes. And if I click on some nodes, then on the right part, I see details about that node. These details are very similar to the details what you receive in the DiagRA S overview for the simulation project. So you can also browse change history, see REST bus simulation data, which is just missing here. There is no data defined. And then you see the list of ECUs. And if I go inside, then we will see diagnostic module for UDS communication. And it has two services defined. So for service 19, where was no DTC defined, maybe no, and unfortunately in that file we have no DTCs at all, but we have some data identifiers for UDS service 22. And if I click on that data identifier, then the list of corresponding responses will be displayed on the right side. And yeah, and also on the left, we see the name of this identifier. And if I want to add a new data identifier, then I can select it from the list. So for OBD, we have a couple of ones here, so it can be easily added. Like, I don't know, if I want to add a vehicle speed sensor to this project, I just select it from the list, click on OK, and then I have a vehicle speed sensor created, but with an empty list of responses. It's not a big issue. We try to add a new one. Click on the button, then there is a dialog. We want to add a response. It shall be enabled. Yes, we don't want to disable it because in that case it will be not used during the communication. Then I can select the type of response. Positive response is fine. I can add some details about that. So how often it will be used for consequent requests. The default value is 1. But in other cases, you can define like for first 10 requests for that data identifier has to be answered with this response, what we are typing here. I can type the response myself here. because vehicle speed sensor is something very easy. It is just a value with 1 byte. I can do it wet way around. If I change it, then the value is updated here. And yeah, we see the physical value. I can click here and also edit physical value myself. So if I say I want to have 100 kilometers per hour, then the tool generates me the value in raw format, and then I can just take it, and then it is assigned to the corresponding place in the message. Another way around would be just to generate some response. In this case, it is really easy, but yeah, the tool just supports you and generates a message which matches to this corresponding data identifier in this case. Yeah, for this data identifier, it is really easy to do that, but we might use something more complex one. Let me select the PID01 and add the response here, and then I can generate, and we see it is something more complex. There are several flags existing here, so there is a bitwise interpretation of the message and so on, and you can now proceed with editing the concrete values without having to know how much bytes you need for that case and so on. Yeah, it helps a lot. So now I didn't save this response, but you can do it, yeah, that way. We support you also in our way around. You can also generate the definitions. We will try it a bit later. So where in a bench you will get all the data for this ECU, what would be possible. Yeah, let us try to do that with the ODX database. I think it's the interesting part. I will select our ODX database. I will not save the changes on the project I did. I don't want to do that. So now I have selected the project, and this project has already an ODX database configured. Maybe let us unselect it first. So, and I will unselect it. And this is the normal state, what you would see for your diagnostic projects if you have no ODX databases configured, and if it's not standardized data for OBD or OBD on UDS or ZEF on UDS and so on. So you will see data identifier, you will see responses, but you will see no interpretations in these cases. Yes, so now it is not really easy to edit this data. So you have really to know at which byte and bit you want to do changes to achieve some change in your tool, and to test whatever reaction, or to test how your diagnostic sequence should work in this case. Good. Let us try to assign the ODX database. I will select the PDX database and open it, and then I press OK, and then the tool tries to find out the corresponding ODX definitions for each ECU. And then the data is getting interpreted. We see it has an interpretation of all of these services given for service 31 for routines. And if I click somewhere on these data identifiers, then for each responses, the tool tries to interpret the data. And maybe what I didn't say, if you want to edit this and if you input something wrong, then, for example, if the message is too long, then you get the feedback that something is going wrong here. Yeah, I have to have a look at the time, so we are really far in the time. So I will shortly show you how to generate the data for ECUs, or how to start from scratch with your project if you have an ODX database. For that one, I will just remove everything from the project. So now we don't have any ECUs. We are starting from the scratch. And then, because we have ODX databases or database configured, I can use this function to create multiple ECUs. And for that one, I have to select the diagnostic layers, and we are sure that the IDs are unique. So I will select this layer for the first ECU. So we see all identifiers are the same. and this layer for the second ECU. Now they are selected. I proceed with OK, and the tool asks me if I want to generate some data for this ECU. I would say yes, so whatever is available. And I can also generate all PIDs for service 1, and then I can just remove the ones I don't need. Then it takes a while. And yeah, so in 2 to 3 seconds, now we have a couple of identifiers added to this ECU for each ECU, and also responses for when generated. So we are generating only positive responses and only one response per data identifier. So if I go back here, then we will see these corresponding values. So it makes the editing really easy with the tool, and even here I could edit the values inline, and then they are getting automatically updated. Yeah, it's really comfortable, and this is why we have this professional edition. Good, so I think it should be yeah, I hope it should be clear how to work with this tool. Also, just the basic understanding should be there, and it's really a big comfort if you are working with ODX databases or you want to edit simulation data yourself. I'm switching back to the presentation, and we are now at the summary. You learned about the DiagRA S as a tool for software-based diagnostic simulation. You learned also about the interfaces or APIs which are delivered together with DiagRA S. You learned also about how to simulate diagnostic communication over a physical canvas with the DiagRA S. We also talked about how to create simulation files easily by importing existing diagnostic trace files. And we talked also about editing functionalities in the professional version for OBD or ZEF on UDS, and also with customer-specific ODX databases. And that's actually it. So we had a long session now, and I hope you learned many things, and hope you have many questions about that. And thank you for your attention, and I forward the word to Mario. Mario?
Yeah, thank you also for your attention. Until now, I cannot see any questions from your side, so I have prepared something which we can share, maybe to make something clear. Okay, that's a question to Alex. Can flash processes also be simulated?
Yes. So the tool DiagRA S can also simulate flash processes, and even either you import the trace file from real flash process to the tool, or you can also create just the needed data which is used in the during flash process. For transfer data diagnostic service in UDS, you don't need to create every data. So there is a way how to handle it generically. So you define kind of request pattern and say, yeah, you can all requests to transfer data service will be answered with such a positive response, and it is really easy to do that, and it's the most comfortable way to do that, unless you want to simulate some error behavior. Then in that case, you will need to handle these requests for service 36 separately.
All right, thank you. Next question is, again, to make it clear, what's the difference between professional and the standard version of the DiagRA S?
Good, thank you for the question. So I try to make it clear, so I will repeat it to recapitulate it. And the idea is that the DiagRA S itself, so the basic version, provides a way to create simulation files from the recoding, so from trace files. and you can then edit them if needed with XML editor or any other text editor yourself. And you can simulate everything. So everything what is supported by the DiagRA S is included in the basic version. What is not included in the basic version is a data manager tool. So this professional editing tool for simulation files. So if you want to have support from the tool for editing your simulation files, then you need a professional version. So typically, why we did this, typically some customers has several colleagues which might create simulation files, but they might have more instances, so more PCs where the simulation will be used and just be running, but nobody will be adapting this, because there is just kind of authors of simulations files, and others are just using them because they don't have to know much about that and don't to deal with that. For them, so for the people who are just using simulation files, basic version is definitely enough. For others who really want to support, to get the comfort from the tool to edit the simulation files, I would recommend to use a professional version.
All right, thank you. If you have more questions, just let us know about using the by using the info@rac.de or directly to Alex, or you can also use the feedback questionnaire to tell us your questions. Just keep it in mind if you have something to ask. Next is just an information. If you are a user of DiagRA D, for instance, or DiagRA X, we have a product training website, RA Learning, where you can find information about the trainings about these tools in Russell in German language or on your location. That's also possible. So individual training courses. Again, the information about the questionnaire. You can photograph the code to get to this questionnaire. Yeah, so thank you once again for your attention. I hope it was an interesting, just nearly an hour. Thanks a lot. And bye-bye. Have a great day.
Thanks a lot. Bye-bye.
Und dann machst du?
Okay, sind alle draußen? Prima.
Gut, bis auf Selina. Ja,
Ja, genau.
ist okay.
Das war's. Dann beende ich das Ganze, ja?
Sehr
Okay.
gut.
Also,
Gut.
ciao.
Ja, tschüss, Mario. Schönen Tag. Ja.
Ja. Jetzt können wir verlassen, aber ich mache mal Besprechung beenden. Die Besprechung beenden.